This is the second problem of LeetCode Weekly Contest 502. Count kth roots in a range. So I'll explain you the problem, but before going to the description or explaining the problem, let us go with the constraints. They said that L and R can be till 1 in 9 and K can be till 30, right? So let me tell you what they gave. They gave us three things, L, R, and then K. So from L to R, if I take something like number series L to R, in this, in this space, I need those numbers as Y, those numbers as Y. I am saying it as Y, where Y is an integer. Of course, Y is an integer, and it is nothing but the value of X power K. So we need to just find those y values which are less than or equal to r and which are greater than or equal to L in the range, right? So we need to find that. And what is this y? Y is nothing but x power k is less than or equal to r and L is less than or equal to x power k. So they both are the same things. I need to know what are those integers which are, if I just convert this, I'll just convert this in a few seconds. But let me tell you, how does this graph looks like for y is equal to x power k and k is equal to 1. Let us start with 1. Now, what if x is equal to 1? What if x is equal to 2? What if x is equal to 3? X 5, x and then 10, something like that. When x is 1, I'll plot that graph something like, let me tell you, x is equal to 1. 1 power 1, k is equal to 1, 1 power 1 is 1, y is also 1. So 1 power 1 will be here. X is equal to 2, same. 2 power 1 is 2, 3 power 1 is 3, 4 power 1 is 4. So it will be going in this way. A straight line actually. Now what if k is equal to 2? Our graph will look like 1 power 2 is still 1, 2 power 2 is 4, and 3 square is something 9. So our graph will be going like this. Sorry, going like this. This is just I want to tell you nothing but so that you can get an idea of what we are doing or how the graph looks like. Now, what if I just know how to count these elements? What are those elements? X power k or y, which lies in between L and R inclusive. I'll tell you. What if I say, what if I just initialize my, x power k will be going till r? Then first brute force which you want to go with, the brute force you think is, well, I'll just go from 1 to r, 1 to r. Let me take it as something like, okay, 1 to r, let me take it as x. X will go from 1 till r. And I will check if x power k is in the range, L comma R, then I'll just increment the count. But that doesn't be an optimized one. Why? Because R can be till 1e9. So that will definitely give you PLE, nothing but time limit error. Now let me tell you how we can optimize. What if instead of going to R, what if I just go to R power K, X is equal to 1 to X power 1 by K. Sorry, R power 1 by K. Sorry for this mistake. R power 1 by K. Kth root of R. Why I'm saying this is because we are given with L less than or equal to X power K less than or equal to R. If I apply kth root on all, I'll get it like kth root of L. Kth root of x power k is nothing but x power k power 1 by k. K and K will be cancelled, and there will be only one thing left, which is X. And R is kth root of R. So X will be going till kth root of R. That's it. Count all those integers which are which are greater than or equal to L and less than or equal to, of course, it will be less than or equal to R. So we will not start with 1, we not end our x, we not iterate our x to R. Instead, we will iterate till kth root of R, right? So x will start with 1, x is less than or equal to kth root of R and x plus plus. If x is greater than or equal to L and x is less than or equal to R, we'll just increment our count and we'll just return the answer or the count at the end. Now the problem is you might be confused, but let me tell you how does this work. Let us take L is equal to 8, R is equal to 30, and K is equal to 2. Now, L is equal to 8, right? So 8, 9, 10, and so on. There will be nothing. Let's take 2, 3, 4, 5, 6, 7, 8, 9. So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36. But if you see one thing, one thing is I will get only these three values 3, 4, 5, 9, 6, 16, and 25. Why I am going to x starting from 1 and kth root, kth root of r. Why I'm going, I'll tell you. I'll tell you one thing. R is equal to 30. What is the square root? Square square root of 30. It is not a perfect square, but it is 5.4. Now, where did I end it? At 5 itself, right? 5.4 is the square root of 30. So, it's better to go till, kth root of r. But if you see, if I ended it with less than 5, I wouldn't be getting 25. So I'll go, instead of 5, I'll go with 6. Nothing but kth root of r plus 1. That's it. So our x will be starting with 1 and going till kth root of r plus 1. And if that x, 3, 4, 5 are the integers only that are being counted, right? So now the value 3 square or 3 power 2 should be included in the range, right? So the x should be x power k should be in the range L comma R. So our algorithm or the code will be something like this, right? So the y is nothing but the value power of x comma k should be this value y should be greater than or equal to L and less than or equal to R. Then we'll increment our answer. And if you see the max or the maximum range I can go, the x can go is power of R power r power of 1 by k plus 1. As I said, 5 will be something like, if I don't go with the 5, I'll missing some counts. I have also given the code link in the description, and thanks for watching this video. If you have any doubts, please let me know in the comment section. Please do like, share, and subscribe to my channel. And if you have any better approach than this, please let me know. And before signing off, let me tell you, you might say, bro, kth root of r will be large for 1 in 9. Now, for 1 in 9, what if k is equal to 1? I need to go till kth root of 1 in 9 is still 1 in 9. So that's why I am writing here, if k is equal to 1, return r minus l plus 1. But what if k is equal to 2? We are reducing. That's why the root, kth root, 1A9. Let me just do the calculation. I don't know whether the calculator to power kth root of 123, 123, 123. Sorry, kth root 31,000. Yeah, 31,000 is still less, right, for this algorithm. So the maximum which I can go is 30K iterations, right? So if you have any doubts, please let me know. Thanks for watching this video.